Hello and welcome to part 2 of lesson number 8 in Unit 1 Linear Systems in our grade 10 academic math class. This is the last video in the unit, which is very exciting. It's a long unit, lots of new things. Hopefully this is the crown jewel, which is applications of linear systems. We're looking at 3 types of word problems. In the first video, we looked at relative value reasoning problems, which are number problems. Typically, we do our let statements, one for the first number, one for the second number. We come up with a couple equations. We solve. Again, it depends on the question. Could be substitution or elimination. Good form also dictates a therefore statement at the end. The second type that we looked at in the first video was break-even problems. These ones, again, are typically 2 different situations, and you want to find their point of intersection where their x and y defined variables are going to be the same. In this case, it was a vacation package. At what point in time, how many days into the vacation did the package cost the same in these 2 different scenarios? This question specifically was just asking how long was the vacation. We did our let statements, our equations, then we solved, and we only needed to find one of the 2 variables, which is nice, and then popped a therefore statement on there. The last type of question we're going to be looking at are age problems. Now, age problems are tricky, for sure. They follow the same setup though, so let's go through this. Molly is 5 years younger than Roger. In 4 years, she will be half his age. How old are Molly and Roger? Okay, so let's let M represent Molly. This is weird for me because I actually am going to be using letters that are not X's and Y's. Oh, we'll see how we do. Molly's current age, you'll remember this from the setup lesson, lesson number 7, is that we want to be focusing on her age, or the people's age at the current time. And we're going to be measuring her age in years, and we're going to let R represent Roger's current age, and that is also going to be measured in years. There we go. Okay, now we've got a couple equations to make. Let's change up the colors. So we have Molly, who is 5 years younger than Roger. So remember when we're setting these ones up, we have Molly, and we got Roger. Now Roger is 5 years older than her already. So, or Molly, I guess if you want to say it like the question, is Molly is 5 years younger than Roger. So in order for their ages to be equivalent in the current time, in the present, we need to do one of 2 things. So since Molly is currently 5 years younger than Roger, we can just add 5 years to her life, and then they're going to be the same. Similarly, we can subtract 5 years from Roger. It comes out the same, so it doesn't really matter. I'll just go with this plus 5 on this side because it looks a little better in the equation that I've made up for myself. So we add 5 years to Molly's age, and then we get Roger's age. That's in the present, and that's equation number 1. Equation number 2, in 4 years. So we're going to time travel these guys. So we're going to say Molly, go 4 years into the future. Roger, go 4 years go 4 years into the future, and then we are going to see what we have to do to make these equal. So in 4 years, she will be half of his age. So again, at this moment, she's half his age. If we want these things to be equal, we need to do something. So if she's half of his age, if we multiply Molly by 2, which is like the opposite of sort of cutting something in half, they will be equivalent. We could similarly, if you wanted to, we could actually divide Roger by 2. Now that introduces fractions, so let's steer clear of that. Instead, let's just multiply Molly's age by 2, and then it will be equal to Roger's 4 years in the future. So there's our equation number 2. This, ladies and gentlemen, it certainly takes a knack to kind of understand how to do these. So practice makes perfect. Don't get discouraged. Keep working the questions out for sure. And now we're going to solve here. So we already have a really nice representation for R, so we're going to do substitution again. So we're just going to sub 1 into 2 into 2. All right, so we have here 2 Molly's plus 4 equals, now in the place of the R, we are going to be putting an M plus 5. So that's going to be, again, just for the sake of clarity, M plus 5, and there's our plus 4 as well that we applied to Roger being projected 4 years into the future. Okay, so let's do the math, some math here that's going to be necessary to get these things bracketless. So we're going to multiply 2 by these 2 terms here. That's, whoops, I'm working in green. So that is going to be 2m's plus 8 and that's going to be equal to, so here we have m plus 5 plus 4, that's just going to be m plus 9. And now we just got to move some things around. So let's transpose. Let's transpose all the constants to the right side of the equation. I'm going to do that by subtracting 8 from both sides. And I'm going to bring this m over to the other side by subtracting m from both sides. That's 1m I'm subtracting. And that's then going to give me 2m minus 1m is going to leave me with another m. And 9 minus 8 is going to give me 1. So Molly's age currently, in the present, is going to be 1. And now we are going to sub m equals 1 into, and again, we can just pick, number 1's probably the easiest because it's already got Roger's age all nice and isolated there. So we have m plus 5. So m plus 5 is going to be equal to Roger's age. So the m value we believe to be 1 plus 5 equals Roger's age. That's going to give us 6 equals Roger's age. And there you have it. So therefore, Molly is 1 and Roger is 6. And Roger is 6. Now again, I don't want to spend a ton of time doing checks here because I don't just want to keep eating up the clock, but let's just have a quick look and see if this makes sense. So Molly is 5 years younger than Roger. That makes sense, right? Because if he's 6 and she's 1, that is 5 years younger than the 6. That makes sense. Now the second one's a little bit trickier, so let's make sure that that one works too. So in 4 years, she will be half his age. So in 4 years, she's 1. In 4 years, Molly's going to be 5. And in 4 years, Roger, who is 6, will be 10. And 10, 5 is indeed half of 10. So it works out. That's a nice little check. Again, not really a formal check or anything like that, just me kind of using math based on the words just to make sure that we got where we needed to get to. Got our let statements for current age in years, again, current age. We get our couple of equations, trying to make sure that they're equal, that they're balanced. We, in this case, used substitution. We subbed in, found one of our variables, took that, subbed it into one of the first two equations, got the second variable sorted out, put a therefore statement on there, and I just did a quick little dummy check. So there you go. Homework's at the bottom. They're just worksheets attached to these lessons. Good luck with the homework. As always, if you have any issues or any troubles or struggles, and I fully anticipate that in this unit, reach out via email, our classroom video chat that's open daily, as well as in person if you're in the classroom. We'll get you sorted out. I'll give you some guidance if need be. I can make some videos that show you the solutions to some of these word problems. And yeah, good luck with the homework. Good luck with the review for the Unit 1 assessment. This is the end of Unit number 1. Good luck, and we'll see you in the next unit.